Hello students, welcome back to one more session of the bridge course. In today's session, I am going to explain an important concept of physics, an important terminology that is used, and that's about units. Now what exactly units? To understand that, let me take the help of the chalk which I am using. So I have a chalk in my hand and I want to measure how long this chalk is. To measure how long that chalk, I'll make use of a scale. I'll use a meter scale and then I'll measure it, and when I measure it I'll get some number, correct? And once I measure, I will write that number. So let this be 10.5. So what I have basically measured here is a quantity, and any measurable quantity is called as physical quantity. So what is a physical quantity? Any measurable quantity is called physical quantity. After measuring the length, I can measure how heavy this chalk is. So I can measure the mass, and then I am going to drop this so that it will fall on the floor. Then I can find what is the time it takes in reaching the floor. So I can measure its time. I can measure its weight. Mass is different, weight is different. So likewise I can measure its density. So lot of quantity I can measure either with the help of some instruments or with the help of various quantities. I can measure the various physical quantities. So what is a physical quantity? Any measurable quantity is called physical quantity. And after measuring, we write a number, right? And the number is called the magnitude. It's called magnitude of the physical quantity. Now after measuring, we use one standard quantity, and that standard quantity in terms of which a physical quantity is measured is called unit of a physical quantity. So what is the unit of a physical quantity? It is the standard quantity in terms of which a physical quantity is expressed. It's called unit of a physical quantity. Now this unit is, when I am using the word standard quantity, because it's a universal. Everywhere the same standard is used. For example, the standard which is used here is 1 centimeter. 1 centimeter. So this is the standard, and that's called the unit. After measuring the mass of it, let this mass be 20. That is the magnitude. What is the standard that is used? The standard used is 1 gram. 1 gram. So that's what is called standard. Everywhere you go to any other countries, the standard is the same. So mass in every country is measured in terms of the same standard, and that standard quantity is called unit of a physical quantity. So it is decided by a members representing various countries, and they decide that let this be the standard throughout the world, and that standard is called as physical quantity. If the length is measured here in centimeter, elsewhere also it's measured in centimeter only. If you go to some other country, they don't measure the length in gram. So that's why it is called standard. So what is standard quantity? A standard quantity in terms of which a physical quantity is expressed is called unit of a physical quantity. Now the question is this unit exist for each and every quantity? The answer is no, because there are certain physical quantities without the unit, and there is a reason for it that we'll see later. Example, have you heard of the term called refractive index? It's used in optics. And refractive index is a physical quantity, but that physical quantity has no unit. It has only magnitude. Magnitude means the number that is used to measure that, that's the magnitude. And along with the magnitude, there may or may not be that standard quantity which means there may or may not be unit. In some case there is unit, and or most of the cases there are units, but only few cases there is no unit for a physical quantity. So here the standard is 1 centimeter, the standard is 1 gram, correct? The standard can be even 1 kilogram, understood? 1 kilogram, that is the standard which is used. So therefore that standard quantity in terms of which a physical quantity is expressed is called as unit of a physical quantity. So therefore after measuring there is a magnitude and there will be unit for a physical quantity. May or may not be unit. But if you just write the number, the measurement is not complete. The length is 50 watt, centimeter, meter, kilometer, foot, watt. So that's why that writing standard is mandatory. Not only that, moment I write the unit, I will come to know, I have measured the length. So unit will help you to understand which quantity you have measured it. If I just say number 10 watt, so you will start thinking what I have measured, whether I have measured acceleration, whether I have measured force, velocity, length, mass, time, watt, correct? If I write 10 second, see now you understood what I have measured, 10 second. Second is the standard, right? Standard used for what? To measure the time. So that's why I have measured the time. So the unit will always help you to understand which physical quantity that I have measured. And it's universal, right? So everyone will come to know what I have measured. It's not different for different person. Just like Aadhaar card. So this is the standard. Hope you have understood what I mean by unit of a physical quantity. So therefore after measuring we have magnitude, and then there may or may not be any unit. Clear? Okay. So what is a physical quantity? Any physical quantity which is measurable is called as a physical quantity, like mass, length, time, velocity, speed, acceleration, force, energy, momentum. There's a huge list of physical quantities in physics, and that's what we are going to learn in various chapters. Okay? Right. Now, out of so many physical quantities which you have mentioned, which we measure, there are few physical quantities which are considered as fundamental. So what do you mean by fundamental quantities? Quantities which are independent of other physical quantities are called as fundamental quantities. So initially they selected 3 physical quantities as the fundamental initially. So scientists believe that these 3 quantities are enough to understand the rest of the physical quantities. So which are those 3 physical quantities? One is length, and then mass, and then time. So which are the 3 initial physical quantities selected or randomly, it was arbitrary as fundamental quantities? It is length, mass and time only. These are the 3 fundamental quantities. And then rest, all the other physical quantities can be derived from these quantities, and that's why they are called derived physical quantities. So what are derived physical quantities? Quantities which can be derived from fundamental quantities are called derived physical quantities. What are fundamental units? Units of fundamental quantities are called fundamental units. Like length is measured in centimeter or meter or foot. Mass is measured in gram or kilogram or pound. Time is measured in second. So these are the units. So units of fundamental quantities are called fundamental units. What are derived units? Units of derived quantities are called derived units. Which are the derived units? Like if I have to take example. Okay, by the way, what are derived quantities? All other quantities other than the fundamental are derived. Velocity, speed, acceleration, force, energy, these are all derived quantities. Okay. So let's take example. Velocity is a derived quantity. What is the unit of that velocity? It is a meter per second. Later you will come to know how. Then unit of force is a Newton. So these are all derived units. Units of derived quantities are called derived units. Conserved physical quantities. Out of so many physical quantities, there are 5 physical quantities which remains constant in all the process, and such physical quantities are called as conserved physical quantities. And those 5 quantities are mass, energy, linear momentum, angular momentum, and then finally electric charge. So these are the 5 physical quantities which remains constant in all the process, and they are called conserved physical quantities. System of units. A system of units is a group of units assigned for various physical quantities. That includes both fundamental as well as derived units. So system of units is a group of fundamental units and derived units. Together is called a system of units. Group of units is called system of units. So very quickly let me explain these terms. Any measurable quantity is called as physical quantity. The standard quantity in terms of which a physical quantity is expressed is called unit of that physical quantity. Quantities which are independent of other physical quantities are called as fundamental quantities. Example, mass, length and time. Derived quantities. Quantities derived from the fundamental quantities are called derived quantities. Velocity, acceleration, force, momentum, energy. Units of fundamental quantities are called fundamental units, like gram, kilogram, meter, centimeter, second. These are the units of fundamental quantities. They are called fundamental units. Units of derived quantities are called derived units. Meter per second, Newton, joule, meter per second square, correct? So many are there. Then quantities which remains constant in all the processes are called conserved physical quantities. These are the 5 example, and there are only 5 conserved physical quantities: mass, energy, linear momentum, angular momentum and electric charge. And what is the system of units? It's a group of units consisting of fundamental units and derived units. Together is called system of units. So let's see more about the system of units. Now there is one system of units which is called FPS system. FPS system. What is FPS system? In FPS system, the length is measured in terms of foot. Okay, foot. So FT is the notation used for that, and this F stands for, from the foot. In another system, which is a mass is measured in terms of the pound. It's measured in terms of the pound. Okay, and the symbol for that is LB. Now, what is this? From where this symbol comes? LB. It's from a Latin word libra pondo. Okay, which means the weight. Okay, so that's how this LB symbol is used, because L is not a letter in any of this word, correct? So that's how the word has come from. It's again from the Latin. Time is definitely measured in terms of the second, and the symbol used is S, small letter S. Okay, so here FT. So this is how the first letter of all the 3 will give you the name of the system. That's why it's called FPS system. What does FPS system stands for? foot, pound, second system. In this system, how many fundamental quantities are there? Only 3. Which are those? Length, mass and the time. So this is one system of units, and this is also called as a British system. And the system is still used, in United Kingdom, where they measure the mass mainly in terms of the pound. They don't measure in terms of the kilogram. And the length, foot, we still use that, correct? So our height, if I say my height is 5 feet and 8 inches, so I'm using the unit called foot. So therefore these are not outdated units, they are still used, and second, still commonly used unit. Okay, so this is one system called FPS system. The other system is called CGS system. In CGS system, the length is measured in terms of centimeter, C, centimeter. And when you write the unit centi, it has to be small letter C and small letter M, okay, centimeter. Then the mass is measured in terms of gram. The symbol used is a G only. So gram, don't write GM. That's a wrong way of writing. For gram, you have to write only single letter G. See, 10 gram, this is wrong. You have to write 10 G only. If you write like this, this is, how do we read this then? Then this is gram meter. Okay. So therefore, there is certain standard way of writing the units, and you have to write and you have to follow that rule very strictly. Okay. Right, so that's G. And the time is measured in terms of second only. So the first letter you can see CGS. So this is the second system. So how many fundamental quantities are there? Only 3. CGS system, there are 3. Even in FPS system, there are 3. Okay. The third system is called MK system, where the length is measured in terms of meter. Meter. Meter spelling is METRE, meter, small letter symbol used, meter, single letter, okay, meter. So we use even this spelling also, meter, METER. Then we have another spelling, meter. So pronunciation is same, you can say meter, 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 correct? So, but they have different meaning here. This is the unit, meter, METER. What is METER? It's a device, thermometer, voltmeter, ammeter, barometer, correct? Measuring device, rickshaw meter, correct? No. So that meter is this METR. And for the last, I am not going to give any explanation. You are smart enough to understand that. Okay. That's length. How about the mass? It's measured in kilogram, small k. Kilogram, small k, it has to be small. If I write capital K and then like this, then this is not kilogram, this is Kelvin gram. Capital K is used for Kelvin. So you have to write the proper symbol. That is what I said, that units, writing units has to be correct when you write or when you express any physical quantity. Time is measured in seconds. So time in all the system is measured in terms of the same system of units. Are clear? Right. But the scientists, they understood that these 3 fundamental quantities are not enough to derive other physical quantities. So there are only 3 in all the 3 systems, CGS, FPS, in MKs, length, mass, time only. So they added 4 more physical quantities, and then that new system is called as SI system. It's as System International. So in SI system, there are total 7 fundamental quantities are there. So this is the new system, and this is the system which we follow right now. So CGS, FPS, MKS is an old system. That doesn't mean that we are not going to use those units. They are still used, but the latest system used to measure physical quantity is nothing but the SI system, in which there are 7 fundamental quantities are there. 3 are the same, which is mass, length, mass, time. Okay, the order, it's all right. You can write this first, no problem. Mass, length, and time. And what are the units? Same as that used in MK system. Okay, right. Now, which are the 4 more physical quantities which are added? See, the first letter here is a L, and then A, and then T, and then E. This is a way to remember that, okay? Late. L stands for luminous intensity. A, amount of substance. Then we have LAT, late, temperature. And then E, electric current. Understood? So, which are the first three? Length, mass, time, which you can very easily remember. After that, remember the first letter of the four quantities. It is late. L, luminous intensity. A, amount of substance. T, temperature. E, electric current. Okay. So these are the 7 fundamental quantities which are used, and they are independent of other physical quantities. So how many fundamental quantities are there in the entire system of units or the new system? 7. And all the rest of the quantities, all remaining, they are all derived quantities. Velocity, acceleration, energy, momentum, torque, force, potential energy, kinetic energy, linear momentum, angular momentum, efficiency, refractive index. They are all derived physical quantities. Okay. So what are the units of these 7 fundamental quantities? The first unit, length, it's measured in meter. Mass is measured in kilogram. Time is measured in terms of second. And luminous intensity is measured in terms of candela. Okay. The symbol used for that is CD. Then we have amount of substance, which is measured in terms of mole, and then temperature in Kelvin, and finally electric current, which is measured in terms of ampere. Okay. See the symbol used. First, length. It's in meter. So M is the symbol, not MTS, single letter M. Then the mass, kilogram, small k, and then G. Then time, second, single letter S. Luminous intensity, candela, CD is the symbol used. Then we have amount of substance, which is mole, MOL is the symbol used. Temperature, Kelvin, capital K. And then electric current, which is measured in ampere, which is capital A is the symbol. Okay. When you write the unit, it has to be small letters only here. Okay. But when you express in terms of the units, you can use a single letter, which is a capital. Okay. So new system, very important, and there are 7 fundamental quantities are there, and those are their corresponding units with the notation that is symbol. Now, in addition to these 7 fundamental quantities, there are 2 supplementary quantities, and these are, one is called plane angle, the other is called solid angle. So what is a plane angle and how to measure this plane angle? Plane angle is measured in terms of the radian. So let me give an example here. So first I'm going to consider a circle like this. This is the circle. Okay. This is the center of the circle. This is the radius of it, R. This is the radius of it, R. This is arc length, which is S. And this angle here, which we measure, it has a theta. Okay. And now I can measure this theta is equal to ratio of the arc length by the radius. So this is how we measure the plane angle. So plane angle is the ratio of the arc length by the radius. And how do we measure it? We measure in terms of the radian. So now tell me, theta is equal to, if I have to consider the entire circle, then what is the maximum arc length possible? Maximum arc length possible is nothing but 2 pi r, which is the circumference of the circle by the radius, right? So this r will get cancelled and we will get 2 pi. 2 pi what? 2 pi radian. You know, this is the arc symbol. So 2 pi radian. We know that already, right? So what's the angle around a point? It's a 2 pi radian, or how much degree? 360 degree. See, that's how we get it. So this is a very important basic formula. So plane angle is equal to ratio of the arc length by the radius. And this is the maximum plane angle possible around a point. Clear with that? So do remember these basics, which we are going to use it in different concept, different topics. So even though it's related to the mathematics, correct, we use them even in physics. Second is solid angle. Now to understand that solid angle, I'm going to consider a sphere. Here I have taken circle, okay. So there I am going to consider a sphere, entire sphere, having a radius r. So r is the radius of the sphere. After that, I am going to consider a small area like this. An area is taken, okay. And the value of that area is a dA. Take a sphere, correct, like this is a sphere, and then take a small area around it. And then join here, at the center. What do you get, when you join? What is this structure called? Correct? It starts from here, like this. What is that structure? It's a cone, right? See, this is a cone structure, conical structure. And this angle here is called the solid angle. This is called the plane angle. It's in a plane, right? The circle is in a plane. Whereas a sphere is in space. This is 3-dimensional. This is 2-dimensional. That's why this is called plane angle. This is called solid angle. And we denote that solid angle in terms of a symbol omega. So omega is equal to ratio of this small area, which is a dA, by square of the radius, r square. So this is how we measure the solid angle. Here it is the ratio of the arc length by the radius. Here is the ratio of the area by the square of the radius. Okay. How do you measure? What is the unit of it? It's measured in terms of a new unit called steradian. Okay, steradian. The symbol used for that is SR. Radian, RAD is the symbol. But for steradian, it is SR is the symbol used for it. Okay, steradian, SR is the symbol used. So what is the maximum solid angle possible? Because maximum plane angle possible is 2 pi radian, 360 degree. What is the maximum solid angle possible? So let's measure that. Omega is equal to, what is the maximum area of the sphere? Maximum area of the sphere. The maximum area of the sphere is 4 pi r square, correct? 4 pi r square divided by r square. So this r square will get cancelled and I will get 4 pi. So the maximum solid angle possible is 4 pi steradian. SR is the symbol used for that. Okay. So this is the formula for plane angle. This is the formula for solid angle. The maximum plane angle possible is 2 pi radian or 360 degree, and maximum solid angle possible is 4 pi steradian. So hope you understood and hope you are following all this, because these are all part of our syllabus. There is a chapter called Units and Measurement. So basically I am giving introduction to this particular concept or a topic called units. So how many fundamental quantities are there in the new system? There are 7. How many supplementary quantities are there? There are 2. So which are those 7 fundamental quantities? Length, mass and the time, and then luminous intensity, amount of substance, temperature and electric current. Which are the 2 supplementary quantities? Plane angle and the solid angle. What are their units? Radian and steradian. What is the symbol of radian? RAD. And for steradian, it is SR is the symbol used for it. So these are the different units of length, which are commonly used. 1 inch. See here there is a image of a foot ruler, correct? This is 0. This is 1. And from here till here, this is 1 inch. On the other side of the foot ruler, So here it's exactly opposite. This is 90 because it's inverted. This is 91. This is 90. This is 91. Okay, not 16 and 90 because it's inverted, right? Now from here till here, it's 1 centimeter. So in your foot ruler, on one side, the units can be measured, or the measurement can be done in centimeter. On the other side, we can measure in terms of the inches. But normally, we use centimeter measurement and we don't use much of the inch measurement. Now 1 inch is equal to 2.54 centimeter. This 1 inch, if I equate here, that will be equal to 2.54 centimeter. Similarly 1 foot, 1 foot ruler, correct? Ruler. So that will be equal to 30.5 centimeter. Length of 1 foot is foot ruler is 30.5 centimeter. Okay, so that's the units of length which is used for the measurement. Then we have units of mass. These elementary particles, fundamental particles, their mass is very, very less. So instead of expressing them in terms of kilogram, like mass of the electron, it's 9.1 in 10 to the power minus 31 kg. The mass of the proton, so 1.67 into 10 to the power minus 27 kg. This is such a small value, 10 to the power minus 31, 10 to the power minus 27. So that's why to express these masses very easily, we use an alternative unit which is called atomic mass unit, 1 AMU, 1 AMU, atomic mass unit. And 1 atomic mass unit is equal to 1.66 into 10 to the power minus 27 kg. 1.66 into 10 to the power minus 27 kg. So that's the conversion from AMU to kilogram. So again we use this conversion, and you have to remember all these conversion because whenever we need them for the calculation, we do the conversion. Okay. Then, so we have 1 pound which is equal to 0.45 kg. 1 pound is equal to 0.45 kg. And then we have 1 ton. And 1 ton is 1000 kg. 1 ton is 1000 kg. So this is the smallest unit of mass used. Smallest unit of mass is atomic mass unit. The largest unit of the mass that is used is called Chandrasekhar limit, which is 1.4 times the mass of the sun. So Chandrasekhar limit, CSL, is equal to 1.4 times the mass of the sun. That's 1.4 times. What is the mass of the sun? It is a 2 into 10 to the power 30. And that will give you, it's a 2.8 into 10 to the power 30 kg. So this is how we can convert 1 Chandrasekhar limit to kilogram. So the smallest unit of mass, EMU, the largest unit of mass is Chandrasekhar limit. So different units of time, we use it. So you get to see a diagram in which the earth is rotating about its own axis. Can you see that? It's an incline and then it's rotating, it's get rotated about its own axis. And we call that as solar day. So for 1 day, earth rotates about its own axis once. Okay. And 1 solar day is equal to exactly 24 hours. And in that 24 hours, a day is completed. That's why it is called solar day. Right. So this is solar day. Right. Now, you get to see a moon revolving around the earth. A moon completes 1 revolution around the earth. The earth is here. This is the moon. So what do we call that? When a moon completes 1 revolution around the earth, and it's called the lunar month. It's called lunar month, which is equal to 27.3 days. 27.3 days. So we don't consider a month which is 30 days. That is not the lunar month. The lunar month is 1 where a moon completes one revolution around the earth, and that takes 27.3 days, and that's called the lunar month. And here we have the earth revolving around the sun. And what do we call that? Time taken by the earth to complete one revolution around the sun. And more interesting, see this diagram. As the earth comes nearer sun, it moves faster. Check that. See, it's moving faster because of the greater gravitational force. And then as it goes away, the speed decreases. See, it's slowing down. And as it comes closer, it moves faster. Okay? And the time taken by the earth to complete one revolution around the sun. So we call it as a solar year. And that solar year is exactly 365.24 days. It's not 365 days, it's 365.24. See, because of that 0.24, after 4 years, if you add that 0.24, 0.24, 0.24, it becomes almost 1 day, correct? So that's why we add that one extra day after 4 years, which we call it as a leap year. So that is because of this. So therefore, time taken by the earth to complete one revolution around the earth is called solar year, and one solar year is exactly 365.24 days. 24 days. So you can see how exactly the earth changes its speed as it goes away and increases its speed as it comes closer to the sun.